Alright, in this video, and again, please subscribe if you find these helpful. In this video, we're going to talk about the product rule for finding derivatives. And the normal notation for the product rule, let's assume f of x and g of x are two differentiable functions. Then this f of x times g of x, that would be the product of these functions. So to find the derivative of a product, you simply use this formula, and the formula is you take the first function times the derivative of the second function, and then add to that the second function times the derivative of the first function. Now, since addition is commutative, then you can write this the other way. You can write the g of x f prime of x first and the f of x g prime of x second. And actually, since multiplication is commutative, you could actually here say g prime of x times f of x if you wanted to, and over here you could say f prime of x times g of x. So I always tell students it's kind of hard to mess this up because of the commutativity of addition and multiplication. Now, I like this shorthand notion. So rather than f of x times g of x, let's just let u represent f of x and v represent g of x. So that way we know that u and v are both functions of x. And so the derivative with respect to x of u times v would just be u times v prime, where v prime is the derivative v, and then plus v times u prime, where u prime is the derivative of u. Okay, so let's do our first example here. So in this example, we have 1 minus 3x squared. That's going to be my u function. And then my v function is 2x squared minus 3x plus 1. So see, I have u here. So here I have u, and then here I have v. So that's u times v. Now this stuff down here actually goes with my first step, so it doesn't go with this up here. Alright, so what I know that to find the derivative of this, I take the function u, which is actually the 1 minus 3x squared, and then I multiply it by v prime. So here, you could go ahead and just take the derivative here, but I'm doing that fixing to thing here that's telling you I'm fixing to take the derivative. So I'll take the derivative in the next step. So there's the first half of that product rule. Now the second half of that product rule, you take the function v, which is the second function, and then you multiply it by the derivative of u, which is u prime. And again, I'm fixing to take the derivative of 1 minus 3x squared, because that's the u function, 1 minus 3x squared. Alright, now so I have 1 minus 3x squared here. I'll just bring it down right here. And then I take the derivative of this function, and so applying my rules from a basic differentiation, I know the derivative of 2x squared is 4x. I know the derivative of minus 3x is minus 3, and I know the derivative of 1 is 0. So that's just going to be 4x minus 3. And then for the other term, I bring down the trinomial 2x squared minus 3x plus 1. And then I get the derivative of this. So the derivative of 1 is 0, so I don't need that. And then the derivative of minus 3x squared is minus 6x. Okay. Now, the rest of it, if you want to pause the video and work through it, you can. But the rest of it is algebra. And so I tell my students to always simplify your derivatives within reason. So this step here has completed any calculus that was required. And so the next step is just algebra. So what I did is I used the FOIL method and multiplied these two binomials together, and I got this polynomial. And then here I distributed the minus 6x through here, and I got this polynomial. And then I just combined the like terms here to get my final answer here, which is minus 24x cubed plus 27x squared minus 2x minus 3. Okay, so then the next example, I've got a function of t. So here I've got this function, which is u, and this function, which is my v. So I didn't write the uv here this time, but basically I'm going to have u times the derivative of v, so there's my fixing to, and then my v times the derivative of u, and there's my fixing to take the derivative of u. So then I just bring the 2 squared minus 3 down, and then the derivative of this with respect to t, the derivative 4 is 0, the derivative minus t squared is minus 2t, the derivative of minus t to the fourth is minus 4t cubed. So that would give me minus 2t minus 4t cubed. Then I have plus, and then I bring this trinomial down. And then you take the derivative of 2c squared minus 3. The derivative of 2t squared is 4t, and the derivative of minus 3 is 0. And then again, go ahead and FOIL these together, and then distribute the 4t through, and collect like terms. And pause the video if you need to do that. But that's algebra, and I'm not going to teach algebra here. So, and you get minus 12t to the fifth plus 4t cubed plus 22t. Now, if you find any mistakes or you think there's errors, be sure and let me know, and I'll put a note to correct them. But I've taught these for several semesters, and so I think they're pretty accurate. Now, some students might ask me on this one, well, why can't I just multiply this out and then take the derivative term by term? Well, you could do that, but then you wouldn't learn the product rule. And the product rule is important because if you take a look at this next one that involves a trig function, the only way that we can find the derivative of x squared times cosine x is using the product rule. So again, here you can see I gave you the u and the v prime here. So the u is x squared. V prime would be the derivative of the second function, which is cosine x. And then v would be cosine x. And u prime would be the derivative of the first function, which is x squared. Now, so here I have x squared. And if you will remember, I told you previously that the derivative of cosine x is actually minus sine x. So we have x squared times minus sine x. And then I have cosine x and the derivative multiplied by the derivative of x squared, which is 2x. So I have cosine x times 2x. And now when I multiply x squared times minus sine x, I get minus x squared sine x. And then usually when we have something like this, cosine x times 2x, we'll put the 2x in front of the trig function. So plus 2x cosine x. Okay, in the next example, we don't really know how to take the derivative of a function raised to a power yet, but since this is just the second power, I can actually write that as a product. All I have to do is write it as 2x squared minus x multiplied by itself, 2x squared minus x. So in this example, u and v are actually the same value. So u would be this 2x squared minus x, and v would be this 2x squared minus x. So if I applied the product rule, I would get u and then times the derivative of v. So the derivative of 2x squared minus x is just 4x minus 1. And then I would get, let's see, I have u times v prime. Then I have v times u prime. Now here I went ahead and wrote the v over here. So here's the v. And then the u prime would be the derivative here, 4x minus 1. Of the derivative of the first factor. And then again, go ahead and FOIL this, and then FOIL this, and collect like terms, and you get 16x cubed minus 12x squared plus 2x. And that may be fine for your professor, but if he wants it factored, because you're going to have to, at some point, I like to get it in factored form if it's not too difficult. So if you factor a 2x out of this and then factor the trinomial, you can write this as 2x minus 1 times 4x minus 1 with the 2x. So that's the derivative. And I'll tell you the reason that you might want to do this is because it's very important to find the zeros of derivatives. You'll find that out in calculus. And so by writing it in factored form, it makes it easy to find the zeros. Okay. I've got one more here, and then here in this one, u is just x, where v is this sum, sine x, or difference, excuse me, sine x minus cosine x. And so now watch what I'm going to do here. Watch carefully. Since u is x, I'm just going to bring down x. There's the u. And then this is actually the derivative of this difference. And let me show you why. The derivative of sine x is just cosine x. That's one of our formulas. But the derivative of cosine x is minus sine x. So you actually have a minus here. and then when you take the derivative of this, you get minus again. So a minus times a minus is going to be plus. So that's where I got the plus sine x. Okay, now I have to do the second half of the product rule. So I'm going to, here I went ahead and wrote v here. So here's v. And then u prime would just be the derivative of x. And we know the derivative of x with respect to x is just 1. So here I have, so I kind of mixed it around again. So here I have u times v prime, and then here I have u prime times v, which is fine, again, because the multiplication is commutative. And then in the last step, I went ahead and simplified this. If I distribute the x here, and then of course multiplying by 1 doesn't change anything, then I'll get 4 terms, x cosine x sine x, plus sine x minus cosine x. And so that's the derivative of that product. Okay, now we also have a rule for the quotient of two functions, and so I'll do that in the next video.